Hi, I am Aman Tyagi, and today I'm going to discuss photoelectric effect with you. Photoelectric effect was discovered by German physicist Heinrich Hertz in 1887 and was further experimentally advanced and explained by Albert Einstein in 1905. It occurs when a surface is exposed to an electromagnetic radiation above a certain threshold frequency, and the interaction between the radiation electromagnetic wave photons and the electrons of the metal surface results in the transfer of energy between them, and the electrons are emitted. Before talking about photoelectric effect in detail, let's look at the important terms which we will be using throughout this video. First, wave nature of light. Light travels as a wave and has all the characteristics of a wave such as wavelength, frequency, amplitude, etc. Particle nature. Particle nature means that light travels as a beam of photons. Photon. What is a photon? Photon is the smallest packet of energy. Its energy is given by E is equals to h nu, where h is the Planck's constant and nu is the frequency of light. Fourth, emission. In this video, the meaning of emission is the act of coming out of electrons from the metal surface when the electromagnetic radiation strikes the metal surface. Fifth, threshold frequency. It is the minimum amount of frequency of radiation which below the photoelectric emission is not possible. Sixth, work function. Work function is the minimum amount of energy which is necessary to start photoelectric emission. It is given by H multiplied by F naught. F naught is the threshold frequency. This phenomenon is very significant in the development of modern physics because इस टाइम से पहले जो फिजिसिस्ट थे वो काफ़ी कंफ्यूज थे कि लाइट के पास पार्टिकल नेचर है या नहीं, बट दिस एक्सपेरिमेंट एंड दिस phenomenon proved that light possesses particle nature as well. So after this experiment, the concept of dual nature of light was known to be true and was realized after this experiment. So what really happens in this phenomenon is that when a metal surface is struck by an electromagnetic radiation, the charged particles are released from or within a material. The radiant energy may be infrared, visible, or ultraviolet energy. In short, it can be any energy or any ray from the electromagnetic spectrum given shown in this slide, and the material on which the electromagnetic radiation will be striking may be a solid, liquid, or gas, and the released particles, the particles which will be released after the ray strikes on the metal surface, may be ions or as well as the electrons. The laws of wave theory of light were not applicable to this phenomenon, as the maximum kinetic energy of the released electrons did not vary with the intensity of light, as expected if we apply the it was expected if we apply the laws of wave theory and explain it in terms of wave theory, but it was not varying with the intensity of light. It was proportional instead to the frequency of light. So in order to explain these unexpected behaviors, Albert Einstein came up with the corpuscular theory of light, which states that each particle of light or photon contains a fixed amount of energy that depends on the light frequency. So in this theory, the light was not treated as a wave. It was treated as a combination or beam of photons. When the electromagnetic radiation strikes the metal surface, the energy of the photons of radiation is given to the electrons of the metal surface. As soon as the electrons get the energy, they go to the higher state and are excited, and as a result they come out of the metal surface. So the total energy of each photon is given by h multiplied by nu, the frequency of the light. This energy will be used in performing two actions. First, ejecting the electrons by providing them with the energy equal to that of the work function of the metal, and second, the rest of the energy will be used to provide kinetic energy to the ejected electrons. So the maximum kinetic energy with which the ejected electrons will travel is given by hf minus w naught. hf is the energy of photon and w naught is the work function of the metal. Now let's see an animation to help us understand what is really happening in the photoelectric effect. Now, as soon as the electrons starts running and traveling, the electricity starts running in the circuit. So this was all about photoelectric effect, and now let's see some of its applications. First, photovoltaic cells. Photovoltaic cell is a solar cell which you might have seen. It is used to generate energy from the sunlight. Second is photoconductive cells. Photoconductive cells are light sensitive resistors in which resistance decreases with an increase in the light intensity when illuminated. Third is photostatic coping. Photostatic copying is also known as Xerox, which we use to photostat our documents. There are also many other applications of photoelectric effects such as electric eye door openers, light meters. It is also used in photography, and many other applications are there. So this was all about photoelectric effect. Thank you.